So this video is to teach you how to cheat with your calculator on some of the stuff you may not know how to cheat with on a calculator. Number 2, you already know how to do, that's matrices. Number 3 is find the zeros. Zeros are better known as your x-intercepts, or where you cross the x-axis. Now there's two ways of doing this. The first way I'm going to do this is the same way you do it by hand. You set the thing equal to 0. All right, that has to be done. Now you go to y equals. You put a 0 in for y1. So we think of this as y1, and we think of all of this as y2. 256x squared minus 512. You're going to have a calculator to do this in your hands. I mean, borrow one from the library, something. Doesn't matter if it's one of these nice ones. You can't take mine home with you, so don't try. But even an older TI-84 works just fine. Do a zoom 6, just like I've been trying to teach you the last day or two. And you may or may not see it, but this one's nice, you can see it. So this one has decimals, but anyways, on a color edition you see the blue line and the red line. It's second trace, the intersection here, we're going to use the intersect key because we're looking for when intersections happen. So second trace 5, get left next to an intersection, press enter once, twice, thrice. There's your intercept. It says the intercept is at 1.4140 roughly. Okay. The other x-intercept is going to be right here, the other one. So second trace 5 for intersect. I'm going to have to scroll over and press enter 3 times. Sorry, that was negative. This one's positive. It's the same thing. Now, if you look back to the work that we did by hand, because that's what you'd have to do, turns out that's what the square root of 2 is. So you might have to, if it's multiple choice on test, you might have to plug some radicals in and see what their values are. All right, next up, this one. So this will become my y1, and this will become my y2. 5 parentheses x minus 4 all squared minus 100, and a 0 in y2. Zoom 6, I just kind of shorthanded the graph. And the intersections are right there on the screen. Second trace 5 for intersect. Whoop, you got to pay attention to cursor. I'm finding it by pressing these left and right buttons. Enter, enter, enter. There's an intersection. It is at negative 0.470. The other one, second trace 5 again. Press that right button a couple of times till you see that cursor show up. Also pay attention down here and over here. It tells you where the cursor is even when you can't see it, which is kind of important. Sooner or later, this y value will start climbing. And that's when I really got to be on the lookout for it. Still falling. There we go. It's starting to climb. Sometimes you actually miss it. There she is. She got close. Close, enter 3 times. There's the other one, 8.47. I'm guessing on paper this one had some bad numbers. Yeah, it was probably something like 4 plus or minus what? Be 20. So 2 root 5. That should be what the answer was. Well, 4 minus 2 root 5 is that decimal right there. So you're still going to have to go back and just plug in numbers on the answer document. If it's multiple choice, this only works if it's multiple choice because I will not accept decimals as answers. Keep that in mind. Even factoring can be done by using a graph, pretty simple. What you do is you just take the thing and you set it equal to 0, and you throw this in y1, you throw this in y2. And again, the purpose of this is to show you how to cheat with the TI-84. There isn't much that can't be figured out with a graphing calculator in front of you. This is why you take things with calculators and things without, because you have to know how to do both. But zoom 6 it. And it's going to give you some zeros, and we're going to have to work with those zeros. Second trace 5 intersect. I'm going to go after the left zero like I always do. Get close, enter, enter, enter. See, there's that mix, there's that fraction. That's negative 1.666 forever. There's an x value. This is going to be a hard skill for some kids because they never really learned the decimals to fractions equivalencies. There's the other 1.75. Negative 1.666 is equivalent to being negative 5 over 3. I hope that makes sense. This is 3 over 4. Okay, what good does that do me? Well, if this is the zero, if the zero is x equals negative 5/3, then the factor is x plus 5/3. And if the zero is 3 over 4, the factor is x minus 3/4. Now here's the other thing. You're never going to see any of those written on a test. They're going to play with this a little bit. If you 3 both pieces, this becomes 3x plus 5. And if you 4 both pieces, this becomes 4x minus 3, which, if you'll look back on the work I did by hand, is exactly how it factors. Or you can even FOIL it here and check yourself, but that's how it works. A graph cannot find imaginary solutions. Your calculator cannot simplify that. It can actually do the majority of the I buttons. There is an I button. I'm just going to write that. P.S. There is an I button. It does exist. Try using it. All right. It can do 14. It can do all of 14. So here's 14. Negative 16x squared plus 256x plus 18. Do a zoom 6 like I've been trying to get you to do in class. You'll see nothing. You're going to have to look up for this. So I'm going to just take a guess and say the student hits 700 foot in height. So I change my Y max to 700. Hopefully what I see, oh, wow, this dude is dead. Okay, let's take it up to 2,000 foot. There we go, it's leveling off. So I now know how high it goes, or at least I have a visual representation of how high it goes. Now I'm going to look in the future. Let's do 40 seconds in the future. That's more than enough. There's the graph. How far off the ground does a typical student reach their max altitude? This happens, of course, when t is 0. Now, if you can't look at the equation and figure that out, you can hit second trace value, and you can tell let x be 0. It's 18. Who would have thought? 18 foot. I don't know that you need a calculator for part 1, but if you do, you do. 3, after how many seconds has the typical student reached their max altitude? So we've done this in class. Second trace 4 for maximum. I get left. It says left boundary. I press enter. I get right. I press enter, and I enter for a guess. There's the maximum. Now, there is such a thing as calculator rounding here. They use Newton's technique to come up with these things. But it's 8 seconds. You can see it right there, 7.99999. And the maximum height is right there, 1,024 foot. Part 4, during what interval of time is the child's height greater than 100 foot? What I do is I put 100 into Y2. Then I go back and I look at my graph by hitting the graph key. I want to find this number and this number. So second trace 5 for intersect. I like to go after the left answer first. Enter, enter, enter. It's going to be at roughly 0.33 seconds. That's the left boundary. Second trace 5 for intersect. Get my right boundary. Enter, enter, enter. 15.67. And the time is stuck between them. So as long as you're stuck between those two numbers, those two times, you're greater than 100 foot. If you like intervals, it'd be 0.33, 15.67. V, how long is the demonstration of parabolic movement? You still have to understand that the height is 0. Now we've already put this into y1, so we're going to throw that into y2. So instead of 100, put a 0 there, or 3 zeros, doesn't matter. Hit the graph key, because your window's already perfect. And hit second trace 5 for intersect. Obviously it's going to be the right answer, not the left answer. Get your cursor close, press enter once, twice, thrice. 16.07 seconds, roughly. And that kid is done. So there's that one. You can even do 15 in a TI-84. This is the one straight out of your notes that I taught today. It's Monday, by the way, when I'm doing this. This one came straight from notes. You Y1 it, and you Y2 it. Oh, wow. This one may not. Yeah, this is the one in your notes. I'm actually going to do what's called a zoom in. Zoom in. Take my little cursor and get it close to what's going on there. Enter. Ah, there is a little bit of space there. You can kind of see it on the graph. There's that little space where we're not above 0. What I want is I want those intersections with the graph and the x-axis. Enter, enter, enter. So it looks to me like so long as x is less than or equal to 1, this graph is above 0. Or there's an answer right here. I might have to convert it to a fraction. I got 1.33333. That's 4/3, or x is greater or equal to 4/3. And you can do the interval notation from there. TI-84 can't do 16. 17 is a TI-84 problem. Can't do 18. You can do 19. Solve that bad boy, assuming it doesn't have extraneous answers, and it can't simplify radicals, but it can give you decimals. Do a zoom 6. Because of that number right there, your Y max should be around 250, because you got to see that horizontal line written. So set your Y max to about 250. And then you should see at least one of your intersections. You're also going to have to look farther to the right because it's obvious that there's 2 of them. So I set my X max to 20. And then I can find these answers. Second trace 5. I always go after the left one first. Once you get close, enter, enter, enter. It's about negative 4.75, and you just have to plug in numbers and see which ones are closest. Second trace 5 again. I'm holding that right cursor till I get over that right intersection. I'm going to press enter as soon as I get there. Enter, enter, enter. And about 10.75. And again, if this is multiple choice, you're game. If it's not multiple choice, you got to know the algebra. That's how it works. But if it's multiple choice, cheat like crazy with TI-84. I hope you get that. It's quicker for a lot of kids. It's also right every freaking time. So there is how you cheat with a TI-84.